How can scientists actually track molecules moving inside a living body, right down to the atom? The answer? They use radioactive isotopes to follow the journey step by step. Now, let's see how. In this video, you'll learn how scientists use radioactive isotopes to label molecules, trace their movement in living systems, and interpret the data they collect. To start, a radioactive isotope is a version of an element with an unstable nucleus. Because it emits radiation, it can be used as a tiny tracer inside a molecule. To create one, scientists replace a regular atom with a radioactive one, like swapping in carbon-14 on a glucose molecule. The labeled molecule behaves just like the original, but now it gives off a signal scientists can detect. With this tool in hand, researchers can watch molecules in action. For example, tracers reveal how glucose moves through metabolic pathways, showing how cells produce energy or hormones. One key application is medical imaging. In PET scans, patients receive a tracer such as fluorine-18, which accumulates in active tissues. As a result, doctors can see brain activity or detect cancer. Because cancer cells often consume more glucose than healthy cells, radioactive tracers can make tumors stand out, useful for both diagnosis and research. Beyond that, these tracers also help scientists study how organs like the brain or muscles use energy in real time. And that's just the start of what these tracers can reveal. Curious how much you're remembering? Your personalized practice test, flashcard set, and study guide are all waiting for you. Just tap the link now and keep watching. Future you will thank you. With the big picture uses in mind, let's zoom in on a key detail: timing. Each radioactive isotope has a half-life, the time it takes for half the atoms to decay. This tells scientists how long a tracer stays useful before it fades. Of course, using radioactive materials requires safety. That's why scientists follow strict protocols, using barriers, keeping distance, and choosing the smallest effective doses. How do they detect the tracers? Instruments like Geiger counters and PET scanners pick up the emissions, turning them into usable data. By measuring how much tracer appears and when, scientists can track how fast molecules move and where they go. Beyond the human body, these same tools help track nutrients in ecosystems or trace pollutants through food chains. Historically, radioactive tracers changed science after World War II. Classic experiments uncovered how DNA replicates and how fast cells metabolize fuel, transforming biology forever. Compared to other tools, radioactive tracers offer high sensitivity, real-time data, and molecular-level insight, but they also have trade-offs. Radiation exposure is small but real, so researchers need ethical approval before using tracers on people or wildlife. For lower-risk studies, scientists may use non-radioactive options like fluorescent tags or stable isotopes. To recap, scientists use radioactive isotopes as tracers to label molecules, follow their paths, and analyze the data to understand biological systems. Ready to quiz yourself with the content covered in this video? Check out the link in the description where you'll find Quizlet content made just for you.